My talk is called As the Industry Matures, Some Questions for LID. And I think it's pretty clear that LID is being mandated very widely in the U.S. through NPDES permits and certainly in California. And the vision is ultimately really a complete retrofit of LID in the urban environment. So moving forward, I think there's still some significant policy issues that we need to explore. So over on slide 2, one of the first ones that I wanted to bring up was groundwater contamination. I think there's been quite a few studies that show that soil is an excellent filter and also sorbs a lot of the pollutants in urban stormwater, but the stark reality remains that we still have groundwater contamination. And I think part of our issue is that we don't know what we don't know. The Chemical Abstract Society has indexed over 23 million commercially and 23 million chemicals or chemical compounds, and about 7 million of those 23 are in commercial use. So do we know everything that's going into groundwater through the various sources and pathways? Probably not. And I think it's also very clear that groundwater contamination is extremely difficult and expensive to remediate once it happens. It's a little bit like the oil pressure light in your car. Once it goes on, you've done a lot of damage. So I think it's really incumbent on us to be very protective of our groundwater resources. I think that groundwater protections in our current NPDES permits with the Class 5 injection well system and things are likely protective enough at the current scale of implementation, but given that we're going to be having such widespread implementation of LID in the urban environment, I think it warrants another look. You know, the highly soluble contaminants like salts, nitrates, other urban contaminants like VOCs, insecticides, pesticides. You know, we're seeing personal care products and pharmaceuticals showing up in wastewater effluents. I think are all maybe problematic for a future where we have very large-scale implementation of LID. So over on the next slide, kind of another interesting issue, which is low-impact development and hydrologic balance. You know, I pulled the definition of LID off of Wikipedia, and you can see I highlighted there that it's one of the goals is to replicate the pre-development hydrologic regime of watersheds through infiltrating, filtering, storing, and evaporating. But what I think, you know, one of the things we've missed, and over on the next slide you can see it, this is kind of a classic, these pop up in most LID talks, you know, where you can see in an undeveloped watershed you have about 40% evapotranspiration and maybe 50% shallow and deep infiltration. And then when you go down to a highly urbanized watershed over on the lower right there, you can see, you know, with high impervious surfaces, you're down to roughly 15% shallow infiltration and much higher runoff. But over on the next slide, slide 5, you can see that there's still a few issues here. The first one is that the design storm that we're using to size LID control measures in a lot of the U.S. really wasn't developed to replicate pre-project hydrologic regime. It was more of an economics-based, you know, what is practical to store and treat on an economic basis. And there was also a really interesting study recently completed over at I believe it was at the University of Minnesota by Erickson in the Vermilion River watershed that showed that urbanization, irrespective of LID on its own, was slightly increasing the interflow and shallow groundwater recharge rate as opposed to decreasing it. And I think this is something that's been overlooked in kind of the hydrologic balance as applied to urbanization. Some of the sources of this increase that they found were the sewer systems. You know, there's about roughly somewhere between 10 and 15% of water in the sewer system exfiltrates through the pipe joints. And so that's one of the source. Water systems, which are pressurized, actually tend to have an even higher loss. According to the Department of Water Resources, somewhere between 10 and up to 30% of water transmitted through domestic water systems is lost through leakage. And then, of course, we're all familiar with irrigation, particularly in Southern California, for example. We put as much as an inch per week of irrigation on a lot of our yards and areas. And lastly, septic systems. Those are obviously designed to exfiltrate water from 100 to, or from about 50 to 100 gallons per capita a day. So we have this huge or relatively massive infiltration of water going on in the urbanized area, and then we will be increasing that again with low impact development. So over on slide 6, just kind of putting out the question there and postulating that, what is the net result of this change? Ultimately, we're going to see maybe higher interflow rates, higher base flows in urban creeks and streams, rising groundwater with its potential implications that it has on the built environment and existing structures. And what is the quality of this water? Is it appropriate for recharge? I think that potable water discharge from leaking potable systems probably isn't too bad, but the rest of them, the leaking sanitary sewers, septic, and then the effluent even from LID, is the quality of this water going to be something that we want to be on a massive scale in urban areas recharging the groundwater table with? So I think it's appropriate for additional studies needed to take a look at really water balance in the urban environment and determine if some of these issues are going to have some negative unanticipated effects before we get to this relatively large scale of LID retrofit in the urban areas. So over on slide 7, another thing to consider is how to pay for this all. I think John did a great job of showing what the costs are, the estimated costs in the 3 major Southern California LID counties. You saw there, roughly I think 35 billion in expected costs, or 30 billion between the 3 counties. Not something that would be easily accommodated in any municipal budget. So another potential issue here is that we have this massive price tag, but the reasonable assurance analysis that John was talking about, which are essentially modeling exercises using unsteady flow models and fate and transport models, are showing that we're not necessarily coming into full compliance with receiving water standards for all pollutants, even if we have full retrofit of LID. So, what is our really end game here? What's the best way to fund LID retrofits with this $30 billion price tag in Southern California alone? I think one of the real questions that needs to be answered is, and it's not necessarily a technical question, but it's a social question, is what is the acceptable timescale to implement full LID retrofit? I think that environmental groups are looking at much shorter time frames than maybe the municipalities are when you're starting to look at cash flow diagrams and how quickly some of this can really occur. And then also something John mentioned too, I think is important, is what is the maintenance cost of these systems and how are we going to pay to maintain them? Certainly the present worth of the maintenance cost is much higher than the capital cost. And how do you maintain things that are on private development? We're starting to struggle with that right now, and most people are looking at some sort of maintenance districts, something that you can assure maintenance on, because as John pointed out, if you don't have assured maintenance over time, the systems will fail. And I think the general wisdom is that you can't count on private property owners without some sort of policing to carry out this maintenance. So a major question and a major element that we really haven't figured out in terms of how we're going to pay for this, and more importantly, pay for the maintenance. So over on slide 8, I just have some maybe potential solutions, some study ideas for some of these questions. John also brought up multi-benefit projects. I think this is one idea and one way to pay for LID retrofit. You know, if you can show the public that you get multiple benefits for some of these installations, such as improving flood resiliency and improving the aesthetics of the built environment. I think we've done a fine job in most urban areas of just taking water out of the environment, and it's placed a very low value, I think, on water in the public's mind because it's out of sight and out of mind. It's usually very cheap in most cities. So helping to change how the public views and values water through multi-benefit type projects, which could be, you know, green streets and streetscapes that have transit improvements and active transportation improvements, along with bringing water back into the built environment and showing the value and improving water quality in urban settings, I think will be important. Because if we're going to obtain new funding sources for LID and LID retrofit, that's going to come from the public. And if the public isn't valuing water at a different scale than they are today, they simply are not going to pay for the huge price tag that we face. In terms of groundwater contamination, I'm a big advocate of what we call true source control. This is something that we have an initiative for at the California Stormwater Quality Associations. Really, when you look at LID from a certain perspective, it's really just a transfer of surface water pollutants into either the soil or the groundwater. It's not really a treatment for a lot of different pollutants per se. So we need to use true source control, and really that involves either substitution of problematic pollutants and chemicals, or the use of green chemistry principles, which I think we really haven't promoted well in the U.S. and really haven't promoted innovation in the green chemistry sector. And I think it's really where the highest return on investment is going to be for us in terms of surface water and groundwater pollution remediation. The Toxic Substances Control Act, which was passed in 1976, is currently, there's an update to that underway right now, and green chemistry really needs to factor into this discussion in a major way. Over on slide 9, in terms of hydrologic balance, you know, some study areas there. California uses about 20% of its total energy to move water within the state, and this massive importation and exportation of water from different portions in our different geographic areas in our state changes dramatically the hydrologic balance. So what I think we need to move towards is using and reusing water locally. Some examples of that are like the San Diego Pure Water Program, which is really a direct potable reuse of wastewater. We've already talked about some of the others on this seminar. Stormwater harvesting, native plant landscaping is huge. You know, I think in the U.S. we kind of put what plants where we want, when we want, and then just irrigate. And I think that there has to be a paradigm shift there. Gray water use is certainly another technology that needs to be exploited much more. And I think ultimately water needs to be used and reused locally. So, and the smaller scale that we can get on that, the better. So, for example, if we have household recycling systems for both gray water and black water, and trying to reuse water again at the smallest scale possible, I think that that's going to reduce the need for water imports and also reduce water pollution that accompanies those things. So in summary, my last slide over here on slide 10 is that, you know, again, the basic implementation of LID at the engineering level really right now doesn't support this premise of maintaining a hydrologic balance, and we need to, I think, reimagine some of the basic design principles if we're going to achieve that. And just this idea that whole-scale improvement of water quality isn't going to be achieved at the end of the pipe, you know, it's really kind of a fool's errand to think that we can strain a lot of these pollutants out at the end of pipe at really what are nanogram per liter levels. We really need to start looking at true source control and green chemistry for a lot more of our innovation in terms of pollution reductions. And money, lots of money is going to be needed, and the public must support this. So we need to tell a much better story in terms of what the benefits are, and I think multi-benefit projects are one element of that if we're going to get the money we need to get the ball down the field in a measurable way. And so clearly articulating the benefits and, again, changing how the public views and values water, I think, is going to be critical to the future if we're going to be able to innovate the way that we need to and make the decisions that have to be made and fund those in a way that's going to achieve measurable benefit in a time scale that meets collectively everybody's expectations. So that's what I had, and happy to take any questions if there are any.
Before we move to our roundtable, let me ask if there are any clarification questions or other questions for Scott.
I have one quick question. You know, probably Stan can help as well, because you know, I'm a little surprised about the finding by Erickson et al. You know, in Minnesota, or you know, that's where he's from. You know, why urbanization could increase the inflow? That's a little bit counterintuitive.
Yeah, it is. I was really surprised. I'll send you that paper, John, that that they put together. And obviously, it was one study done in one watershed, but I think it has a lot of application, because in urban areas, you know, we all have separate or combined or separate sewer systems. We all have domestic water systems. There are some septic systems, and you know, there's quite a widespread dependence on landscape irrigation as well. So I think it's just been an overlooked piece of the equation up till now, and something that deserves a lot more study.
Yeah, they must have a very, very leaky infrastructure. Otherwise, it's hard to imagine.
Yeah, well, I think you'll find that that's not all that uncommon. You know, most of the water systems and sewer systems are quite old in most of the country.
I was just going to add that that I think this is a very much a watershed by watershed issue. And if you look at the literature, there are definitely examples where as this community urbanizes, base flow in streams, for example, increases, and that's actually true in Southern California. We've had massive increases in base flow, 100%. I think the LA River was 500% over the last 100 years. Most of that is actually coming ultimately from water importation and then making it to the streams, you know, usually in the form of sewage effluent, but in some cases you can also get, you know, increased groundwater. But I guess I was going to ask a question, Scott, pertaining to it sort of as a theme that is in your talk, but it's something I hear a lot, and I find it a bit mystifying, I guess, and that is this this almost making synonymous LID to infiltration. You know, we published this ES&T paper last year, which basically pointed that from the hydrologic balance perspective, that most urban areas would actually need to harvest more water than they infiltrated. You know, as just a sort of blanket statement. Obviously, there's a lot of detail there, but I do encounter this a lot whenever the word LID is uttered. The first thought that comes to mind is infiltration, and then all the barriers to infiltration, including, you know, permeability and groundwater contamination and so forth and so on. really a lot of the co-benefits could come from harvesting locally and using for fit-for-purpose activities. I was curious to get your feed on that. I mean, obviously, you had at the end that harvesting was something that could be implemented, but is part of getting the public acceptance kind of changing the dialogue and the way that we even talk about these systems to some extent?
No, I'll admit that my bias is from Southern California. You know, we've done a lot of studies looking at the economics of harvest in our area, and I think we have a lot to learn from probably Australia still. But the issue is storage. You know, to have any meaningful benefit from storing stormwater in Southern California, you need massive, massive amounts of storage, and we simply don't have it. You know, groundwater storage is the best and cheapest alternative by far, and so that means, you know, infiltration and making sure that we're infiltrating water of high quality. But, you know, we look at rain barrels and any sort of storage on lot, you know, at the on lot level, and it's really the cost benefit is just so far out of whack that it really doesn't make a lot of sense right now.
One other question, then, just to kind of get your reaction. I heard about this from somebody in LA who was talking about maybe using the storm sewer system as a storage device, just as a kind of offhand comment. And then, you know, John mentioned the MS5, and that's actually something that we're actively thinking about is how you could potentially actuate the storm sewer system after a storm to actually use it as a storage, because it is a very massive system that is mostly dry most of the time. Has this thought or idea percolated to your consciousness, and do you have any comments on it?
Yeah, I think it's an interesting. You're right, there is a significant amount of storage in the existing storm drain system, and it would take some infrastructure work. I think that, you know, the biggest issue would be public safety and making sure that that could be, you know, drawn down and used before another storm hit. But also, you know, you guys had talked about the last 5 and using, you know, I think real-time controls for the flood infrastructure, and I think that technology could really go a long way in helping to do that, both in our surface water storage reservoirs, you know, our flood control basins that we have right now, which again are all dry, as you point out, as well as the underground systems. I think that, you know, having real-time controls and operating those as a smart network could definitely go a long way for stormwater harvest, and it's something that I think is a really, really good idea, because it appeals to me because we're getting more performance out of an existing infrastructure element, and I think that if we're going to be spending the public's money wisely, that's definitely one of the things that we need to look for. Absolutely.
That's great. I'm glad to hear that, and I would look forward to including you in that ongoing discussion then.
Absolutely.